Welcome on board the Chemistry Survival Kit, the one and only kit you need to survive in chemistry. You will be experiencing first-hand survival skills through this chemically magical journey. So, what are we waiting for? Let's begin. This is the product manual. Firstly, here are the subtopics. Next, this is the airplane safety video available for viewing as soon as you board the plane and take your seats. We hope you will enjoy your flight with Vine Airlines and will fly with us again. Now, let the airplane safety video begin. Please click the play button when you have fastened your seatbelts. Welcome on board Vine Airlines. Please make sure that you pay attention to our safety video in the case of emergencies. Life jackets are located under every seat. Life jackets for children are also available at your request. The life jacket is a solid that is made up of nylon and plastic. Particles of the life jacket are closely packed in an orderly, regular arrangement. They are held together by very strong forces of attraction. However, they have a very low kinetic energy and thus cannot move about freely and can only vibrate about their fixed positions. To use, remove the vest from its container by pulling on its tab and then opening the pouch. Slip the vest over your head and wrap the strap around your waist and attach it to the belt wall in front. As you leave the plane, inflate the vest by pulling down on the red tab on the bottom of the vest, or manually inflate it by blowing into the tube at the top left-hand corner of the vest. As the life jacket is inflated, it is filled with gas. Gas molecules, unlike the particles of the life jacket, are spread far apart from each other in a random arrangement. Weak attractive forces exist between the gas molecules. Their kinetic energy is very high and they move about randomly at high speeds into available space. In addition, the life jacket will enable you to float on the sea in the event that the plane crashes. Here's some quick information on the particles of the sea. The liquid molecules in the sea are closely packed but slightly further apart than that of solids. They are arranged randomly and have strong attractive forces that are weaker than solvents. The liquid molecules also have low kinetic energy and hence move about randomly at slow speeds within the liquid, only slipping and sliding over one another. That's the end of the airplane safety video. Feel free to ask any of the air stewardess or stewards if you have any queries. Have a safe flight! Oh no! What is happening? Passengers, please brace for impact. Are you okay, Tarzan? It seems as if we are stranded on an island, but look! Wow, we have the survival kit that we saw earlier. We have such a chemical affinity with it. Let's make the most of the situation and explore the wilderness.
Right, don't we need clean water? Look what we have here in the survival kit. It's a large container and a plastic sheet. I know, let's gather up some stones and some sand from the wild. I have an idea on how we will be able to obtain clean water. Firstly, we have to dig a bowl-shaped hole in the ground, and then place the container into the hole. We then place the plastic over the hole and cover the sides with rocks to keep it in place. And then a bigger rock should be placed in the center of the sheet to allow the sheet to hang down directly over the container to form an inverted cone. Water from the ground evaporates as water vapor rises and touches the cooler surface of the plastic sheet, cools and condenses to form water droplets, and then flows down into the container.
Wow, how did all of that happen?
When matter is heated or cooled, the heat energy taken in or given out causes the kinetic energy of the particles to change. As a result, there is a change in state. Here are some other processes in which involves changes of state as well. Firstly, melting, which is the change of state from solid to liquid. Heat energy is absorbed by the particles of the solid. The heat energy is converted into kinetic energy. The particles start to vibrate faster about their fixed positions. And when the temperature is high enough, the vibrations of the particles become sufficient to overcome the attractive forces between them. The particles begin to break away from their fixed positions. The particles are no longer in their fixed positions, and the substance is now a liquid. The particles can now move freely throughout the liquid. Secondly, freezing, which is the change of state from liquid to solid. Energy is given out by the particles of the liquid. The particles lose kinetic energy and begin moving more slowly. When the temperature is low enough, the particles no longer have enough energy to move freely. The particles start to settle into fixed positions, and when all the particles have settled into fixed positions, the substance is now a solid. The particles can only vibrate about their fixed positions. Thirdly, boiling, which is the change of state from liquid to gas. Heat energy is absorbed by the particles of the liquid. The heat energy is converted into kinetic energy, and the particles start to move faster as the temperature rises. When the temperature is high enough, the particles have enough energy to overcome the forces of attraction holding them together. The particles are now spread far apart, and the substance is now a gas. The particles can now move about in any direction. Fourthly, evaporation, which is the change of state from liquid to gas. It is the same as boiling, except it occurs at temperatures below boiling point and occurs only at the surface of the liquid. It also is occurring slowly. Lastly, condensation, which is the change of state from gas to liquid. It is the reverse of boiling. Heat energy is given out by the gas particles during condensation. As the temperature drops, the movement of the particles becomes slow enough for the gas to change into a liquid. Sublimation is a process by which a solid changes directly to a gas without going through the liquid state. Look, there's iodine in a chemistry survival kit. Iodine is a solid that can sublime. The particles at the surface of the iodine have enough energy to break away from the solid and escape as a gas.
Hey, how come I can smell that plant all the way from here? It stinks. Oh, this is due to diffusion. Diffusion is the process by which particles move freely to fill up any available space. The tiny gas particles escape from the surface of the plant, and these particles move into the spaces between the air particles and eventually reaches here. That is why you can detect the smell of the plant. The molecular mass of the gas, which refers to the mass of the particles of the gas, can also affect the rate of diffusion. Gases with lower molecular mass diffuses faster, and those with higher molecular masses because their particles are lighter and hence are able to spread out more quickly. I remember conducting a similar experiment a few days ago.
These are the apparatus we need. We can find them in the chemistry survival kit. A 32 cm glass tubing, rubber corks, cotton wool, aqueous ammonia, and lastly, aqueous hydrochloric acid. So for the experiment, we will place a cotton wool into one side of the glass tubing soaked with aqueous ammonia. Next, we will put another cotton wool on the other side of the glass tubing soaked with aqueous hydrochloric acid. Insert the rubber corks at both ends to seal the glass tube. The particles from both cotton wools will start to travel towards opposite ends. As you can see, the particles of the aqueous ammonia are traveling faster than that of the aqueous hydrochloric acid due to it having a lighter molecular mass than aqueous hydrochloric acid, hence traveling a longer distance. When both particles meet, a white ring will form due to the formation of ammonium chloride. Ammonia particles traveled 29.5 cm, whereas the hydrochloric particles traveled 2.5 cm.
Now that we have learned more about the island, we can start making plans for our future so that we can live on this island. Using the kinetic particle theory, let's find out what application it has in our daily lives. Well, in order to survive on this island in the long run, we will need water, warmth, weapons, as well as shelter. Let's see. For water, other than the clean water we managed to collect earlier on, we will also be able to collect water from water vines. Water can fit into water vines because as a liquid, it does not have a fixed shape due to the fact that the particles of a liquid are arranged in a disorderly manner. The particles have weaker forces of attraction than the particles of a solid. The particles have more kinetic energy than particles of the same substance in a solid state and are not held in fixed positions. And lastly, because the particles can move freely throughout the liquid. Thus, water is able to easily flow out of the vines for us to drink. For weapons and shelter, we can use wood. Wood can be used to make weapons such as spears because wood is a solid and solids have a fixed shape and thus are very hard and suitable for weapons. This is because particles of a solid are closely packed in an orderly manner, are held together by strong forces of attraction, have enough kinetic energy to only vibrate and rotate about in their fixed positions, and cannot move around freely. This is also why wood should be used to make a treehouse for shelter. The treehouse would then be strong enough to house the both of us. As for warmth, we can keep ourselves warm by burning firewood. Heat energy is transferred from the fire to our surroundings through thermal radiation. When the heat energy is absorbed by the surrounding air particles, the average kinetic energy of these particles increase, and the particles move around more quickly. As a result, the temperature of our surroundings increases, and we are thus kept warmer. Oh hey, I found a journal in the survival kit. Why don't we start recording our experiences and take this as a logbook? You were here from the beginning of our journey, so you can help Tarzan fill out the remaining boxes. You also get to choose your own mind map template.
One eternity later.
I'm finally done. Click next to view the concept map done by me. Printing is available. Well, this is indeed a chemically magical journey. Now that we have learned so much, we can continue living and prospering on this island. Now it's time for bed. Good night. If you enjoyed the preview of our e-package, buy the Chem book now. It's buy one get none free, so call us at 6333 6888. Goodbye.